Okay, in this video we will talk about the Q&A about this section. That means that the alternating current through a resistor or an inductor or a capacitor. A pure resistor is connected to an alternating current source with the current supply I equal to this function flows in the circuit. Which statement is not true about the circuit? The root mean square current flows to the resistor is IRMS equal to I0 over square root 2. What is I0? 4. So you know that IRMS equal to 2.83. Actually, in the question, they didn't give us the unit. That means that they didn't state I is in ampere or whatever. But then never mind, we just assume this to be correct first. The maximum power dissipated from the resistor is 628 watt. Okay, you still remember that the formula for the maximum power of the resistor? That means that P0 equal to V0 I0. But then in this question, you are only given the I. You totally did not know about the V. So of course, you have no information of the power. The peak value of the current is 4 ampere. I equal to I0 sine omega t. I0 equal to 4, so this is 4 ampere. So we know that this must be in ampere, so that these two statements are correct. The frequency of the current flows through the resistor is this. Omega equal to 628 equal to 2 pi f equal to 2 pi over capital T. So you know that frequency is like this. Yeah, it is almost 100 Hertz. So this is also correct. So we know that the only statement which is not true is B, because we totally do not know the voltage across the resistor. The variation of the instantaneous power P dissipated by a heating coil with time T when a sinusoidal current flows through the heating coil is shown. Okay, this is what? This is sine square function. Just now you already learned that the power, the instantaneous power of the resistor is sine square function. Okay, this is the maximum power, which is 2000 watts. If the resistance of the coil is 100 ohm, what is the root mean square current flowing through the coil? Okay, this is maximum power, and then you remember the formula for the maximum power of the resistor P0 equal to V0 I0, which is equal to I0 square R. So you substitute the value, then you can get the I0, which is the maximum current flowing through the resistor. But now you want to get the root mean square current flowing through the coil, so you just use this formula, which is the first formula you have learned in this alternating current circuit chapter. Okay, now a filament bulb is connected in series with a sinusoidal voltage supply. Explain how the brightness of the bulb changes if the frequency of the supply is increased but its root mean square voltage remains constant. You know that the resistance of the filament is R. That means that it is independent of frequency, because you can see no omega inside the formula. So you know that no matter how the frequency increases or decreases, the R will always remain the same. So the power is constant. So we will say that there is no change in the bulb's brightness. Okay? The sinusoidal alternating current voltage is applied across a resistor. Which statement is true about the current and the voltage of the resistor? Okay, you know that for a resistor in an alternating current circuit, I and VR are in phase. I is the current passing through the resistor. VR is the potential difference across the resistor. So when they are in phase, you know that the current is maximum when the voltage is maximum. The current is zero when the voltage is zero. The current increases when the voltage increases. Yes, this is correct. The next question. Sinusoidal voltage with a peak power V0 is connected across a resistor of resistance R. The average power which dissipated as heat is... Okay, you still remember the formula for the mean power of the resistor, which is equal to half V0 I0. Okay, this one. Okay, just now in the last video, I asked you to memorize this, and this. Okay, so you know that mean power of a resistor is half V0 I0. Okay, so which is equal to V0 squared over 2R. So the answer is this. State one advantage of using capacitors instead of resistors to regulate current in an alternating current circuit. Okay, you know that for the capacitor there is no mean power. That means that there is no heat lost. So this is exactly the answer. Okay, in the alternating current circuit, the average power of the resistor is not equal to 0. So the resistor will have a power loss, and then the power is lost in the form of heat. But for the capacitor, there is no power loss. Okay, there is no heat dissipated by the capacitor in an alternating current circuit. An electric oven is labeled 240 volt, 1200 watt. If the values are taken to be the root mean square, the peak power of the oven is... Okay, when you see something like this, you know that the first thing is root mean square value of the voltage. The second thing is the mean power. Okay, so now the oven is a resistor. So you know that for the resistor, the peak power is twice the mean power. That means that for the resistor, the mean power is twice. The peak power is twice the mean power. So maximum power equal to mean power times 2. The mean power is 1200. That means that your peak power is 2400 watt. A filament bulb labeled 100 volt and 40 watt is connected in series with a resistor and sinusoidal voltage supply of root mean square voltage 240 volt and frequency 50 Hz. If the bulb lit with a normal brightness, calculate the resistance of the bulb. Okay, for the bulb, you know the root mean square voltage across the bulb, and then you also know the mean power dissipated by the bulb. Then you can use this formula, P equal to VRMS squared over R. So please remember the formula for the mean power of the resistor. Okay, then you can get this answer. Please find the resistance of the resistor. Okay, this is your diagram. That means that you already know the voltage supply has a root mean square value of 240 volt. And then just now you also know that the root mean square voltage across the bulb is 100. So that means that when you know the VRMS of the source and you know the VRMS of the bulb, you can straight away know the VRMS of the resistor. I can straight away add this up because bulb is a resistor. The resistor is also a resistor. That means that they are in phase, so I can straight away add them up. Okay? If this is bulb, this is capacitor, of course you cannot do like this. You have to use the Pythagoras theorem whereby V squared equal to VR squared plus VC squared. But never mind, I will teach them in the following videos. Okay, so remember that I can straight away add them up because they are both resistors. Okay, you know the mean power of the bulb is 40 watt, and then you know the VRMS across the bulb is 100 volt. So you can know the IRMS, and then the root mean square current is 0.4 ampere. Because they are all connected in series, that means the current of the source and the current through the bulb and the current that is flowing through the resistor is the same. They are all 0.4 ampere. And then the VRMS of the resistor is 140. It is equal to IRMS times the resistance of that resistor. So you can know the resistance of that resistor as 350 ohm. An alternating current power supply is connected in series with a parallel plate capacitor and an AC emitter. If an insulator is inserted into the space between the plates of the capacitor, the reading of the emitter will... Okay, first you need to understand that the emitter will read the root mean square current. The voltmeter will read root mean square voltage. They will not read the maximum value. They will only read the root mean square value. Okay, you also need to recall what you have learned in the chapter of capacitor. The parallel plate capacitor has a capacitance of the formula ER E naught D E naught A over D. E naught A over D. So you know that when the insulator is inserted into the space, ER increase, so the C will also increase. And then you know the formula for XC, which is equal to VRMS over IRMS. Okay, this formula is coming from the definition of the XC. Then what is XC? XC equal to 1 over omega C. Then you know that when the C increases, IRMS will also increase. So the answer is increase. Okay. A capacitor is connected to an alternating current power supply. If the frequency F of the power supply is varied, but the root mean square voltage is maintained, which graph shows the variation of the root mean square current with the frequency F? Okay, this is alternating current supply. This is the capacitor. VRMS equal to IRMS XC, and then XC equal to 1 over omega C. So you know that when the VRMS and C are constant, IRMS is directly proportional to F. Okay, so it's this graph. IRMS is directly proportional to F. Okay, just now it's the same. Only when the VRMS and omega are constant, then only you can conclude that IRMS increases when C increases. An alternating current supply of frequency F is connected across a capacitance C. If the peak voltage of the supply is V0, what is the maximum current that flows through the capacitor? XC equal to V0 over I0 equal to VRMS over IRMS equal to 1 over 2 pi FC. So you use this formula to straightaway find the formula for the maximum current. A capacitor is connected to an alternating current source with a voltage of 48 volt and a frequency of 90 Hz. If the capacitance is 3.7 microfarad, what is the peak current in the circuit? XC equal to 1 over 2 pi FC equal to V0 over I0. Then you substitute everything inside, then you can get the value for the I0. The variation of voltage V and current I with time t when an alternating current flows through a certain electrical component is shown as below. Okay, from this graph, you know that V reaches maximum before the I. Okay, and then V leads I by 90 degrees. What is the component? The component is an inductor. Which statement is not true of the inductor? The component is an inductor. Yes, it's correct. The net power dissipated by the component is 0. Yes, there is no heat loss by the inductor. Alright, there is no heat loss by the inductor. The reactance of the component is independent of frequency. The reactance of the inductor is what? Is XL, which is equal to omega L. XL is directly proportional to the frequency. So this is wrong. The voltage leads current by pi over 2 radian, which is 90 degrees. Yes, it's correct. A pure inductor is connected to an alternating current supply. If the frequency of supply is varied but the amplitude of the voltage remains unchanged, which graph shows the variation of root mean square current I with frequency f? Okay, this is the alternating current supply. This is the inductor. V0 equal to I0 XL, XL equal to omega L. I0 equal to square root 2 IRMS. Okay, because you already remember IRMS equal to I0 over square root 2. Okay, so you know that IRMS is inversely proportional to the frequency, and so this should be the answer. Okay, because the V0 and L are constant. Okay, because the amplitude of voltage remains unchanged, so V0 is constant. L is the inductor. The inductor is not changed, so L is still the same. So L is a constant. So only when the V0 and L are constant, then you can straight away say that V0 is inversely proportional to the frequency, then IRMS is inversely proportional to the frequency. Derive an expression for the reactance XL of a pure inductor in terms of its inductance L and frequency F of a source of current supplied. Assume the expression of the source of current supply is this. Okay, this is the inductor in an alternating current circuit. Kirchhoff's second law states that the net potential change in a loop of a circuit is 0. So the V equal to negative back EMF of the inductor. Then you can know that V equal to L di dt. Then what is the formula for the L, please? It's given in the question. You substitute it inside. Then all these things is a constant. L is a constant, I0 is a constant, 2 pi is a constant, F is also a constant. Therefore, this whole thing is your V0. SL equal to V0 over I0. You substitute V0 equal to this one inside. Then you can know XL equal to 2 pi FL. An alternating current circuit contains a pure inductor of inductance 0.47 mH. It is operated by a power supply with peak voltages of 120 volt and a frequency of 90.3 MHz. Determine the peak current of the inductor. XL equal to 2 pi FL equal to V0 over I0. Then you substitute everything inside. Then you can get the value for I0. The peak power in the inductor is half V0 I0. Okay, always remember this. The peak power for the inductor is V0 I0 over 2. V0 I0 over 2. Then you substitute everything inside. Then you can get the peak power of the inductor. A pure inductor is connected to an alternating current supply of constant peak voltage but of frequency which can be varied. Which statement is true about the peak current in the circuit when the frequency is increased? Okay, for an inductor, VL That means that the voltage across the inductor must lead the current passing through the inductor by pi over 2 radian. Not more, not less. So they are automatically out. V0 equal to I0 XL. XL equal to 2 pi FL. So you know that V0 and L are constant. And then Vi0 and F are inversely proportional. So when frequency is increased, I0 decreases, peak current decreases. So the answer is D. Okay. So in the next video, we will talk about the RL series, RC series, and RCL series alternating current circuit. R is resistor, L is inductor, C is capacitor. Thank you.